Hi, and welcome to our session, Ops 203, OpenTelemetry and Observability at Shopify, Splunk, and Google. My name is Morgan McLean. I'm a product manager at Google. I primarily focus on OpenTelemetry, as well as a number of our ops management products, including cloud monitoring and cloud logging.
Hi, I'm Steve Flanders. I'm a director of engineering at Splunk, working on our observability getting data in strategy. I'm an OpenTelemetry collector approver.
We have a packed agenda today, and we're going to have interesting information for those who are familiar with OpenTelemetry and those who are not. We'll begin with an introduction to the project, what OpenTelemetry is, and what the project includes. Then we'll move on to OpenTelemetry and how it fits into the broader field of observability. After that, we will show getting started guides and examples of how you can use OpenTelemetry. And finally, we'll have stories of companies that make use of OpenTelemetry in their production services today. OpenTelemetry has a number of different components, and I'm going to start from the most basic ones all the way to the core implementations that customers are using today in production. To start with, we have the specification. The specification is in many ways the core of the project. It defines the different signals and different data types that you can use to capture telemetry from your application. For example, there's a specification for metrics that defines what a metric is, what a metric can capture, and how you interact with it. Similarly, there are specifications for traces, resources, and logs. Keep in mind that the log specification is relatively new compared to the others, and so it's still incubating. Next, we have a data model. The data model describes how actual APIs and how your code will interact with this data, and how a metric or trace or log or other component is actually described to a computer system. Next, we have API services. These are the different ways that your code will interact with the data model in order to capture correct telemetry from your application. These API services include instrumentation, which allow you to go and create a metric for something like an RPC call, or to define what a trace will look like when you're capturing it from a certain source. Configuration, which allow you to interact with other parts of the OpenTelemetry APIs and SDKs, like sampling, for example. And finally, there's an API for exporters. Exporters are how we send data from an OpenTelemetry SDK or other OpenTelemetry source to other backend components. These backend components might be the OpenTelemetry collector, which is an agent. We'll get to what that is in a moment. And it can do that through the standard OpenTelemetry interchange protocol. Or you can use an exporter to send data directly to a backend like Google Cloud Ops or Splunk. Finally, we also define semantic conventions. These semantic conventions are not so much rules for the machine, but rules for people who are defining instrumentation or capturing data from their applications. For an example of a semantic convention would be how to create a metric for HTTP latency or HTTP QPS. It would include the tags that you're generally expected to add there and the metric names that you would generate. The same is true for tracing. The next level up in OpenTelemetry is the actual APIs and SDKs. We have one API and SDK per language, so there are no competing implementations, and all effort is driven behind that single implementation for language. OpenTelemetry, as I mentioned, has these standard SDKs. Because we have APIs, you can also go create an SDK of your own. As far as I know, I don't think anyone is, but it's totally available for vendors or anyone else to go define their own SDK. And the APIs allow you to go use the sort of API services that I described before to actually go and write instrumentation or to interact with the SDKs themselves. The SDKs contain logic for things like sampling or creating a trace or creating a metric. And so we generally recommend that people use the standard SDKs. And that seems to be what most of the community is doing. Next, we have the collector. This is an optional component. The collector runs as an agent, so whereas the SDKs, you would link them to your application to go capture traces and metrics. The collector, you would then instead run on the operating system. The collector generally can't capture traces and metrics directly from your application. Those have to be done through the SDKs, but it can be used as a processor or proxy that you send that data to before it gets exported to your final destination. And it makes things like configuration a little easier, and it makes just a sort of generally cleaner, easier export path to send data to your backend of choice. The collector can also capture system metrics, so metrics from places where you can't use the API and SDK. Think of memory consumption or disk consumption. It can do this for Windows and Linux. And the collector can be deployed as an agent on a particular operating system. In that case, you also get the system metrics if you want them. Or it can be deployed as a service so that you can access it and send data over the network. The collector also contains receivers for metrics from Prometheus and traces captured from Zipkin or Jaeger clients. There's also some new components that have been added to OpenTelemetry fairly recently. These are auto instrumentation agents for Java, Python, and JavaScript, and we're adding some other languages soon. These will take some of the functionality you would normally get in the SDK, like capturing traces from an app, and they're able to perform that functionality without having to link to your application and rebuild it. Now, they're not as sort of generally useful as the SDKs. The benefit of the SDKs is you can go define a custom metric, or make changes to trace annotations, or use any of the APIs natively that you want to. You can't do that with the auto instrumentation agent. But if you have an application that is difficult to recompile or rebuild, or one that you don't have the source code to, the auto instrumentation agent is a great choice. OpenTelemetry entered beta in March. This was a big effort by the community, and we're incredibly proud of the accomplishments we've had. And this is why you see some firms and some organizations already using some OpenTelemetry components in production systems. Specifically, the March beta included the Java, Python, JavaScript, and Go SDKs, as well as the Erlang SDK, and I think the .NET SDK is about to hit beta or already just has. The beta also included the collector. The beta was very focused on tracing functionality and also included metrics functionality. We're targeting a GA later this autumn. The GA will be, prior to the GA, we'll have several release candidates coming out that will be sort of pre-GA versions, and eventually, once we're very satisfied with one, we'll declare that as the final GA version. Expect those release candidates to start rolling out later this summer, and the GA to take place then later this year.
Okay, so let's talk about observability, specifically in the context of OpenTelemetry. As Morgan mentioned, there's a specification, which is basically the foundational part of the OpenTelemetry project. The specification can be data source specific. So, for example, there are specifications for both traces and metrics. And inside each of those specifications is some rich information about how you actually define the information, the telemetry, that you're trying to admit. In the case of traces, this includes like the spans and different attributes that are attached to those spans. In the case of metrics, you have labels and the ways that you actually account for the different metrics that you care about in your environment. You can actually drill into these. They're all on the GitHub repository if you're interested in learning more information about them.
Next, we have resources. So, as the slide describes, every OpenTelemetry signal is tied to a resource. And if you think about this, this makes sense, right? If you're capturing metrics from your application or traces from your application, they're not particularly useful unless you know where each metric or where each span of a trace actually came from. There's different levels to these resources. You can go as low level as the actual information that describes the actual machine that a metric or trace came from, all the way up to higher level concepts like services or Kubernetes containers or deployments from which you're capturing this data.
Semantic conventions are also extremely powerful. The idea is, how do I actually define this thing that I'm calling? Like, for example, if I have a REST endpoint or I'm calling a database, if there was a way to just normalize that information so it didn't matter which vendor or backend I was sending my data to, I could still query it out in a unique way, that would be extremely powerful. And that's exactly what semantic conventions try to do. By offering a standard way of actually instrumenting, you can then leverage any backend of your choice in order to query the data out and get the insights that you care about. True observability. Now, in the case of tracing, context propagation is probably one of the most fundamental pieces. It's basically how you glue everything together. So when you have your service to service calls, you're actually passing context between those calls. You can actually see a representation of this on the right hand side. This is actually from the Jaeger documentation. Basically, you call into a service and you generate context. You then pass that context as you make other calls to downstream services within your environment. That context can also be shared within the application for functional level calls. But this context propagation concept actually goes beyond distributed tracing. For example, I probably want to share metadata between my different data sources, and I can do that through the correlation context specification information. In addition, I need a way to actually share that between my APIs and SDKs, and the propagators is how we do that in the OpenTelemetry project. There are links to all this information if you're really interested in learning the specifics of it, but this is really the magic that glues all the information together and makes it extremely useful when you want to actually query out and get insights from them. So let's talk a little bit about getting started with the OpenTelemetry project. The easiest way to do that is to really start talking about the architecture. So you can see here we have a host, there's an application running on it, and maybe we have one or even multiple backends we want to send our data to. How do we get started with OpenTelemetry? Well, first we're going to go ahead and deploy the OpenTelemetry collector as an agent. The reason why we do this is kind of twofold. One is it can go ahead and grab the system metrics for you automatically and send that to the backend or backends of your choice. Secondarily, if I actually leverage the OpenTelemetry collector as an agent with the OpenTelemetry client libraries, then it's automatically configured for me, thanks to the use of the OTLP protocol that is built into the OpenTelemetry project. So if I deploy the OpenTelemetry client library and an agent is already running there, the traffic will be received, both metrics and traces, eventually logs, and all that data can then be sent to one or more backends based on configuration rules that I write in the collector itself. This provides flexibility and also offloads some of the responsibility from the application itself. Things like buffering and retry, encryption, compression, all that can actually be offloaded from the application, which would consume resources and actually be handled in a single language. In the case of the collector, it is Go, one way, and be handled across my entire fleet. Another deployment architecture is actually to have the collector running as a standalone service. That would be typically in the same data center or region. I would deploy one or more of these collector instances, and usually it's the agent that will forward to the collector. Now, the idea here is maybe I want to limit the number of egress points I have in my environment. So I don't want all the agents to talk to the internet to send to my vendor's backend. Maybe I want to consolidate the API keys. Maybe I want bigger buffer or retry queues, and so I can offload this to a set of collectors that I can scale up or out as needed. There are different use cases for this. Another one would be around tracing. Maybe I want to do tail-based sampling. That typically doesn't follow an agent model. You typically need standalone collectors in order to achieve that. And the OpenTelemetry collector is actually a single binary that can be deployed as either an agent or as a standalone service and is very configurable depending on your use cases. So next I want to talk about auto instrumentation, because if you've never got started with instrumentation before, it may seem like a lot to actually get going. And really OpenSymmetry is trying to make this be as easy as possible. And then later on, you can get to manual instrumentation if you want to add your own custom metric or tracing information, your own metadata, and enhance what's available out of the box. The idea with auto instrumentation is it's basically runtime parameter changes to your application, not code changes. So it's very easy to get started. Here's an example of a Java application. Let's say I have a Java call to a jar, the jar that I've written that runs my application. All I need to do is go ahead and define a Java agent parameter and point to the OpenTelemetry Java agent all jar file. In addition here, I've gone ahead and set an environmental variable, which will set the service name, so I know what this service actually is and how it will be represented in the backend that I'm forwarding that traffic to. That's it. I then just fire up my application and I can go ahead and get rich trace data automatically for any supported library. And there is broad support for this today. Here's an example in the case of Java of all the different libraries and versions that are supported. Now, this slide is probably already out of date because new ones are being added every single day. So go ahead and take a look at this and feel free to contribute additional ones. But it provides broad support and really can get you started with distributed tracing information with little development involvement in order to get you started. Now, with that, I'd like to show you a demo of how you can actually get started with both the OpenTelemetry collector and with Java Auto Instrumentation.
Okay, let's go ahead and fire up the demo application. While it starts up here, I'll explain to you what's going on. First, we're going to be leveraging the Spring Pet Clinic microservices example application. It's all based on Java, and it's actually multiple different microservices that communicate with one another. As you can see, they have a picture on the repository on what it looks like from an architectural perspective, and the applications are actually not instrumented by default. So our goal here is going to be to add OpenTelemetry Java auto instrumentation to the Java microservices and to have them report to an OpenTelemetry collector, which can then send to the backend or backends of your choice. So what I've done is I've actually modified this repository. I've added a collector.yaml, which will go ahead and define how we want the OpenTelemetry collector to be configured. In this case, I'm basically just accepting over the OTLP protocol and defining an endpoint where I can actually send traffic to a Zipkin server. And this only needs to be defined once. In addition, basically how that Spring Pet Clinic microservices example app works is through a Docker Compose file. So each of the microservices is a different Docker container. I've gone ahead and made the following modification. Basically, I've enabled the Java agent runtime parameter, which you pass first right after the Java command, and I'm pointing it to the OpenTelemetry Java agent all jar file. And then I am defining a service name via an environmental variable. So in this case, we have the discovery service. And I've repeated that for every single microservice that's in the Docker Compose. So you'll see customers and visits and vets. Finally, I have defined an OpenTelemetry collector that actually gets spun up as well so that these microservices can all report to a locally running OpenTelemetry collector that uses the collector.yaml file that I just showed. For each of the microservices, we have a Docker file, and in that Docker file, we will go ahead and get the jar file from the OpenTelemetry project so that we can embed it at runtime as a parameter and have it do bytecode manipulation of our application. So that's about it. And then what ends up happening is this microservices app gets fired up and starts reporting traffic to an OpenTelemetry collector. You can actually see here log lines of different spans already being reported into the system. So just by firing it up, we haven't even accessed the UI yet. You can see the data is being generated and being sent to the backends of my choice. So I will go ahead and start up the Pet Clinic application. You can see it's here. We can go ahead and look at, let's say, any owners that are in the system, any veterinarians that are in the system. We can go ahead and add additional information as well. You can actually interact with the system in multiple different ways. And the net result here is, in the case of Zipkin, we can go ahead and look for any traces that are coming into the system. We can do this by service name. So for example, maybe I'll go ahead and go take a look at discovery service and see that there are actually traces coming into the system. And we can actually drill into these and see a variety of different calls that are being made and associated metadata. We can actually see this is coming from the OpenTelemetry project as well. Now, I've actually modified the collector to also send to the Signal Effects backend. So here's another example where, again, the data is being sent to two different backends. So I can actually compare, or I can send different data to different backends. Really, OpenTelemetry is looking to be vendor agnostic and provide a generic way of handling instrumentation for you. So you can do it once and not have to worry about it afterwards. So exact same data here. As you can see, you get a visual topology. This basically represents what we saw in the architecture diagram of the GitHub repo. And as you can see, I made no Java changes in order to get this instrumentation and actually get some rich insights, both from a visual topology perspective, as well as my red metrics, request, error, and duration, and any other metadata that's associated with it. So that's a very quick demo on how you can get started with OpenTelemetry, both the auto instrumentation and the collector. And without making any code modifications, only runtime parameters, we're able to get some rich telemetry data out of our application.
Thanks for the demo, Steve. As I mentioned in the beginning, there are already companies and groups that are using OpenTelemetry in production services today. Google is one of them. Starting back in January, we actually deployed the OpenTelemetry collector into instances of Google Kubernetes Engine versions 1.16 and above. The OpenTelemetry collector since then has formed the backbone of the metrics pipeline inside of GKE and replaced a number of deprecated components like Heapster. Similarly, we'll be using OpenTelemetry for Cloud Ops customers, particularly Cloud Monitoring and Cloud Trace, to replace the existing open census-based SDKs that they use to capture application metrics, custom metrics, and distributed traces. Next, we're going to be using OpenTelemetry inside of Google Compute Engine. We have a new Windows system monitoring agent that's actually based on the OpenTelemetry collector, using a lot of the system monitoring, system metrics capabilities that I talked about during the introduction. Beyond this, we'll be using the collector to replace our Linux monitoring agents probably later this year or early next year, and that will bring in the same capabilities that we're bringing to Windows right now. At that point, I think effectively all of our metrics and tracing stack will have been moved over to OpenTelemetry, at least when it comes to capturing data from customers' applications.
At Splunk, we're also leveraging OpenTelemetry extensively. We basically have this broken up into two different categories of work. Internally, we want to actually consume and leverage OpenTelemetry as much as possible. So in the case of Signal Effects and Omnition, all of the infrastructure today is leveraging the OpenTelemetry collector in order to collect both metrics and trace information. We're actually actively underway moving to OpenTelemetry client libraries as well in order to get rich insights and move to an open source, vendor agnostic, and open standards way of gathering telemetry data from our own environments. Externally, we are active contributors to the project. We're actually maintainers of the collector as well as the Java auto instrumentation. And we're working very closely with the community to donate some of the signal effects open source components around the smart agent, gateway, and other auto instrumentation semantic conventions we've been working on. Finally, we're about to get kicked off with the .NET auto instrumentation SIG. So if you're interested in that and really want to get involved, we'd love to have your help. All right, next up, let's hear from Francis about how Shopify is leveraging OpenTelemetry.
Shopify is partway through a migration from a custom trace collection infrastructure to one based heavily around OpenTelemetry. In addition, Shopify is one of the maintainers of the OpenTelemetry Ruby client library. At present, our architecture looks like this. We have a large number of trace services written in several languages and instrumented in different ways. Some of these are externally developed, such as CoreDNS and Nginx. Some use our custom instrumentation and export in its custom format. Some export in Jaeger's format, some in OpenCensus, some in Zipkin. The OpenTelemetry collector is the core of our architecture. We add a couple of components to it, in particular a receiver for our custom trace format and a custom exporter. Our use cases for the collector include PII redaction, downsampling for cost control, adding tags required by vendors, renaming spans to control cardinality, and fixing instrumentation flaws. Here's an example of PII redaction in the collector, focusing mainly on database queries attached to spans by the instrumentation, but also with app-specific redaction. At the top, we redact any database statement tags, unless the span also explicitly indicates that no PII is present. Lower down, we identified that PII can leak into the job args tag for this service, so we explicitly redact those tags.
So, you just heard from a cloud provider, Google, a vendor, Splunk, and an end user, Shopify, about different experiences leveraging OpenTelemetry. As you can see, there is broad support and broad interest in this topic. In fact, OpenTelemetry has the second most contributions in all of CNCF behind only Kubernetes. That's pretty exciting. And we would love to have you come join us. You can get involved in the conversation on Gitter. You can come join a special interest group depending on which area you care most about. And there are tons of great issues, both with help wanted and good first issue labels to get you started. Please come join the community. Please come join the discussion. As Morgan mentioned, we're just getting started with the logging specification. So if you're interested in logging, now's a great time to get involved in that as well. We would love to have you be part of the solution to this important problem for the industry as a whole. And with that, thank you so much for joining us. We really appreciate it, and we hope to see you in the OpenTelemetry community soon.